Hello there. Welcome to my YouTube channel. Today I will take you through the overall heat transfer coefficient. Let's tackle this question. A mild steel tank of wall thickness 12 mm contains water at 95 degrees Celsius. The thermal conductivity of mild steel is 50 watts per meter per degree Celsius, and the heat transfer coefficients for the inside and outside the tank are 2,850 and 10 watts per square meter per degree Celsius, respectively. If the atmospheric temperature is 15 degrees Celsius, calculate 1. The rate of heat loss per square meter of the tank surface area. 2. The temperature of the outside surface of the tank. Solution. Here is a diagrammatic view. Given. Thickness L equals 0.012 meters. Temperature of hot fluid THF equals 95 degrees Celsius. Temperature of cold fluid TCF equals 15 degrees Celsius. Thermal conductivity K equals 50 watts per meter per degree Celsius. Heat transfer coefficient of hot fluid HHF equals 2,850 watts per square meter per degree Celsius. Heat transfer coefficient of cold fluid HCF equals 10 watts per square meter per degree Celsius. 1. Finding the overall heat transfer coefficient, U. U equals 9.94 watts per square meter per degree Celsius. Finding the rate of heat loss per square meter of tank surface. Which equals 795.2 watts per square meter. 2. Finding the temperature T2 of the outside surface of the tank. T2 equals 94.52 degrees Celsius.